obtaining the centroid of a compound shape. First of all, we must select a coordinate system, z, y. Place the origin of the z-axis to the middle of the bottom edge. The z-axis is aligned with the bottom edge. Due to symmetry around the y-axis, the centroid should lie on that axis too. In other words, in the remaining, we'll focus on finding the centroid coordinate y. Divide the compound shape to a number of simple geometric shapes. This beam cross-section consists of two rectangular segments. Find the centroid of each simple shape in the z-y coordinate system. Centroid of rectangle is defined as the center point where all the diagonals intersect each other. Find the area and static moment of each simple shape. To find the area of a rectangle, we multiply the length of the rectangle by the width of the rectangle. The first area is 2 times 8 is 16 square centimeters. Second area is 6 times 2 is 12 square centimeters. Static moment is the product of a quantity and the distance from that quantity to a given point or axis. Take a small area A within the cross-section at a distance y from that z-centroidal axis of the beam. The first moment of this area is static moment. The second moment of this area is moment of inertia. All calculation we will summarize in a table. To find the static moment of a rectangle, multiply the area of this rectangle by the y-coordinate this rectangle. Find the total area. 16 plus 12 is 28 square centimeters, and find the sum of static moments around z-axis. Knowing the total static moment and the total area, we can find the centroid coordinate. A compound beam shape may be welding or gluing two beams together, or it may be made by extruding or rolling. Aluminum extrusions are widely used in architecture, machine parts, furniture, automotive components, and other consumer goods. Steel is hot-rolled into railroad rails and wide-fledged structural steel beams, channels, and angles. Draw construction lines on a cross-section and analyze it as if it were glued together with rectangles, sharing a common centroidal axis. The moment of inertia for the entire shape is moment of inertia first rectangles plus moment of inertia second rectangle plus moment of inertia, third rectangle. Let's find the centroid of a beam with the hollow space. The beam and the hollow space must have the same centroidal axis. We can see symmetry around the z-axis. Therefore, the centroid should lie on that axis. So, in the remaining, we will focus on finding the centroid coordinate z. Divide the compound shape to a square and semicircle. Find the centroid, the area, and the static moment of each simple shapes. Knowing the total static moment around y-axis and the total area, we can find the centroid coordinate z. The moment of inertia is a term used to describe the capacity of a cross-section to resist bending. It is always considered with respect to a reference axis, such as x or y. If a beam is hollow and the hollow space shares the same centroidal axis as the beam, then we can subtract the moment of inertia of the hollow area from the moment of inertia of an equivalent solid beam. For a square beam with a semicircle hollow section, the moment of inertia is the moment of inertia square minus the moment of inertia of the semicircle. Thank you for your attention. Happy practicing!